First of all, thank you for joining our first webinar in 2023. So you probably see more coming up this year. So stay tuned with A6. So let's start off our webinar today. Hello everyone, thank you for joining our first ACIGS webinar series in 2023. I'm Sue, Secretary of ACIGS. Today we will be talking about geosynthetics for sustainable development in a really casual sort of discussion format, together with board Ramsey, Preston, Kendall, and also our invited guest, Jonathan Shamrock. But before we start off with the webinar on sustainability, I just wanted to take a few minutes to introduce IGS and also our local Australasian chapter. So IGS is a global society with somewhere around 44 local chapters. We have more than 4,000 members, including corporate, individual, and student members. So to join a society, you can either join the local chapters like the Australasian chapters, where we have our own chapter in Australia responsible for this region, or you can join through their websites. So the website is written on top of the screen, geosyntheticsocieties.org. On the website, you actually find all the information related to geosynthetics from the technical committees of societies for different applications. You have the information for local chapters, what are the latest news, what are the latest events in your region, where you can actually find calendars for any upcoming conferences. So the digital library is probably one of the most useful functions on the website once you join IGS. So it includes all the proceeding of past conferences, videos, webinars, technical documents, as well as really important access to two geosynthetics journals, which is really, really useful. So Australia is home to the Australasian chapter for IGS, or in short, A6. So we have our own chapter website, a6.org. You can see on top of the screen as well. So all of the information on the chapters actually being written in the website. So from membership information for individuals or company members, for example, to events that we are organizing. We have roadshows coming up. We have more webinars coming up this year. And also we are looking at organizing conferences in the year to come. So there are also a really good resources of webinars. We have uploaded more than 30 webinars that we have hosted for the past years on the website with a lot of interesting topics being discussed. So do take your time and check out the website. The webinars are actually free to access. And if you are interested to join the society, your memberships actually allows you to access the digital libraries from the IGS database. So I really highly recommend you to join our society if you're interested in knowing geosynthetics better. So for anyone that requires a certificate of attendance, please do email info@a6.org. Good afternoon, morning, evening, everyone that joins the webinars, and welcome to our first webinar in 2023. And as I've mentioned earlier during our introductions, we will have our webinar today on geosynthetics for sustainable development. Joining us today, we have Boyd Ramsey and Preston Kendall. Both of them are co-chair for the Sustainability Committee of the IGS, International Geosynthetics Societies, as well as we have Jonathan Shamrock, which is a senior engineer there in New Zealand. So he is the chair for TC Barriers, and also he's actively involved in a lot of issues considering the Pacific Islands. Correct me if I'm wrong, Jonathan. So let's start off with the webinars. I would probably ask Boyd to have a quick introductions on the sustainability committees. Boyd, please.
Thank you, Sue. Yeah, just so you, the audience, know who you're working with or learning about. This is a listing of the current membership of the IGS Sustainability Committee. And Preston and I are the co-chairs. I'm very happy to work with Preston. But take a minute and look through this as I'm talking. It's a pretty darn impressive group. Not all these members are intimately involved in everything we're doing, but I think this is a very strong commitment from the IGS, recognizing that sustainability is not only a big issue, but an issue where geosynthetics have a whole lot to contribute. So these are all our members, a whole lot of experience with everyone there. And I'm very proud to work with Preston and to represent this group. And if I can continue, the output of the Sustainability Committee largely comes out on the IGS website. Almost all of the documents we print, create, publish, etc., are listed here. We're going to talk about them over the course of the webinar, but I would strongly urge that you go to the IGS website. There's a whole lot of resources available for you, your company, your country. There's good information there, and like I say, we're gonna talk about it. But I wanted to put this slide in the beginning so everybody knows where it is and knows where to find it.
Yeah. Thanks, Boy. I think I've been to the website by myself, and I think there are super a lot of information, and it also gives the readers a different angle, a different perspective on how geosynthetics will be able to actually help in terms of sustainable sort of developments in the future and current as well. So to not waste too much of a time, I think let's hop into the first topic to discuss. So this webinar, it's less of a presentations. It's more of a discussion in between the few of the panels and their experience in the industries, their experience and knowledge in what geosynthetics would be able to help, and how we can able to use geosynthetics to contribute to a better ways of constructions, better ways of giving back to the environment. So in terms of how should we be thinking of geosynthetics, what sort of ideas the panels would be able to provide to the audience? Boyd, if you want to start off.
I'll let Preston kick off with this one.
Sure. Thanks, Boyd. Yeah, so I think geosynthetics really sit in a unique category of materials, somewhat modern material, since the perhaps 1950s and 60s they've been implemented. And they have special properties in their durability and strength, which basically really opens up the toolbox for engineers to make use of them. So they're unique in their strength and durability, and then their long-term use applications. And that's, it's not often that civil engineering materials are invented, but we can say that, the geosynthetics are relatively new and a very, very important one for modern engineering.
Yeah, and I think also that there's probably a certain differentiations from what an engineered geosynthetics are used for compared to plastics waste that, for example, single-use plastics that we have been hearing about recently, and how we tackle them.
Yeah, so I think we'll talk about this also further on, but the problem is that the single-use disposable straw is made of polyethylene, the same way many of the geosynthetic materials are made of polyethylene. So they're the same chemical material, but as Preston described, their functions are dramatically different in terms of the benefits they bring to society and in terms of the durability of their use. Yeah. There's just a huge difference. I mean, a lot of plastic waste gets burned, and that's maybe better than putting it in a landfill, but there's a broad range of benefits. Clearly, geosynthetics are at the top of that pyramid. We provide great infrastructure benefits for a really long time for most of our installations.
Yeah, and I think we'll get onto the benefits a bit later on as well, but there's specific products like geomembranes for containment that there's just not a natural barrier that works as well as a good composite geomembrane with clay or with a GCL. in terms of keeping what you want out of the groundwater, there's just no natural way of doing it as well as what you can with a well-designed and installed geosynthetic product.
And I think probably a lot of people doesn't realize that a lot of infrastructures, a lot of constructions that are building around us are actually incorporating geosynthetics in a way to actually improve its functions. A lot of the materials are all buried underground that people doesn't really see the benefits of it. So the usage of geosynthetics and the purpose of it being used, it's a lot of time hidden from the publics, but I think that there are a lot of benefits that we can actually pull up from these materials. We can talk about it in the next few slides. Yeah.
Yes, Sue, that's a nice segue into the one of the resources available on the website. The committee's published a series of materials called Did You Know? And these are one-page descriptions of how our materials are used and what they're used for. And they're designed with the layman in mind. You know, if somebody doesn't know what a geosynthetic is. So that's a resource that our audience could use.
Yeah, that's really correct on board. And if you look into what sort of positive emphasis on geosynthetics in terms of its contribution to sustainability, I think we can definitely tap into these few points that we have on in front of the screen in terms of emissions reductions, savings, in terms of some examples that in lowering environmental impacts. Does any one of you have any comments on that? We can start it off. Jonathan, for example, if you have a comment on that.
Well, yeah, I mean, just the one that jumps out to me, there's methane, and there are a lot of barriers used in either landfill caps or in oxidation pond caps that keep the methane in so that we can extract that through a landfill gas extraction system or through a degassing system underneath the ponds and make use of that gas. A lot cheaper to build a facility like that than to build a massive big steel tank with a expanding roof. These can get put out by farmers and they can use that gas, and it prevents the methane, which is many times more harmful to the environment than CO2 is from getting out. And then on the emission reduction side, there's a lot of geosynthetics that can be used in the place of a natural materials. So thinking, for example, of using a geosynthetic clay liner, a GCL, instead of a compacted clay liner, where I think the rough stat is something like 70% CO2 saved if you use a GCL, because you only need to bring a few trucks to site to cover the same area that you would with a very thick compacted clay layer, and that's the equivalent. You need probably 600 to a meter of clay to get to the same level of environmental protection as a 10 millimeter thick GCL layer. And then there's also a lot of potential to use geocomposite drains as opposed to using natural stone with geotextile both sides, specifically in landfill caps. So you putting a geocomposite drainage layer in can save a significant amount of CO2.
Yeah, I do agree. And I think for our sustainability committees as well, I would imagine that there would probably be quite a fair bit of questions coming from the communities, from the engineers, that questions about the positives, benefits of having geosynthetics incorporated into their designs. How would they be able to tap on the benefits of the materials? Preston, Boyd, do you have any comments on that?
Yeah, well, I think you're seeing more emphasis on sustainable concepts in design. And so asset owners and governments want to see reduced impacts on projects. And geosynthetics can deliver that in a variety of ways. I mean, and I would even sort of just to add to Jonathan's point, I see the you've got savings in energy, transport. There's a lot of things that might not be immediately obvious. All of the trucks that transport all of that heavy haul trucks that have to transport all that clay have an impact on the roads as well. And someone has to maintain those roads. And so these benefits really bring on second order benefits as well. And this is something that any, regulator, government body, even asset owner would like to see in the outcomes of a, civil project.
Yeah. And
So let me tie this together into some of the work that the committee is doing. One of the things that the committee has been working very hard over the last several months to develop is a geosynthetic sustainability benefits calculator. Several companies publish, information and even calculators on their website about how their products perform. One of the things we've learned is when you speak as an industry, you get heard by regulators much better, and much more attention is paid than individual companies who have a profit motive, obviously. So we're trying to publish something, taking the existing research and publishing it as the IGS. We think that that'll bring a great benefit to the regulatory community, because this is becoming rapidly much more and more sophisticated. This is not just something you plug a few numbers into an Excel spreadsheet. Now you're working off a company's environmental product declaration. Their EPDs are very important, and a source, and you're choosing whether you're going cradle to grave, cradle to gate. There's all sorts of engineering choices that have to be made. And there's software available now that wasn't available, even a year ago, that takes these calculations and allows the engineer to play with the variables and make various decisions, again, so you can demonstrate the benefits of the geosynthetic materials. So we're probably a couple months away from that, but I think that's going to be a very strong contribution to allowing engineers and owners to see the benefits of geosynthetics in all the topics you have listed here: transport, time, emission reduction, CO2 reduction, all of those. But we need to document it in a form that the engineers use.
yeah.
So the key kind of standout on this page for me is that sustainable word and the sustainable infrastructure word, because if it's possible to build something for less emissions, less cost, and for the resultant to be more resilient, that's a win on quite a few levels. And I think geosynthetics offer that compared to building something with just traditional natural materials.
Yeah, I think having the IGS coming up with a software or calculators for that, I think it really helps engineers to understand the benefits of geosynthetics in their projects. So looking forward for that. Let's have a look into probably one of the hotter topic to discuss today. We have some current issues that has been discussed fairly frequently in the market and globally as well. There are topics about microplastics and how it would affect the environment. In terms of, I think there's a highlight that Jonathan probably would be able to talk more on the Fiji plastic ban, and as well as some global regional perceptions on plastics use.
Yeah, so this came up when I was involved in a project in Fiji to do an extension of an existing landfill, and we ran afoul of a recent bit of law that had been passed that essentially was aimed at banning the importation of polyethylene for plastic bags, because they wanted to do a plastic bag ban. But the way it had been written, the contractor who was trying to bring the material in to line this landfill basically couldn't differentiate between a roll of HDPE that's coming in to line a landfill as an engineered product versus a roll of HDPE that was coming in to make plastic bags. So there was a little bit of engagement with the government, and I think we're at a point now where I think there's an understanding that those two things are different, but it was a little bit of a process to basically explain that difference between an engineered product versus something that's designed to be thrown away.
And Jonathan, I'd say this is also a harbinger of things to come. I mean, we're not going to solve the plastic problem without governmental involvement, but that governmental involvement that is not properly educated can be very dangerous. I mean, you just gave a great example. There's also information on the IGS website about a submission that the IGS made to the European Commission on sustainability. They had some severely mistaken ideas about how geosynthetics worked. In the UK, for example, they're starting to tax materials that don't use recycled plastics. That packaging issue is coming. And it's important that the IGS serve as a appropriate discussion point with the regulatory community to represent our materials properly, so that so that the right materials are available and the benefits are appreciated. I've more to say about plastics, but I'll let Preston talk for a little bit.
Yeah, I mean, no, what you guys have said is spot on. And I think an area where the Sustainability Committee has gotten involved, which wasn't initially foreseen, was to correct and highlight poorly cited and misguided research, which did have the potential to, impact decisions on limiting these really beneficial use of geosynthetics. So it was important for us to get in and put geosynthetics in a proper context for the European Commission, to highlight where it's used and how it's used, and why really geosynthetics are not going to be a substantial contribution to microplastics. Most of the applications are entirely buried and don't have any abrasive forces on them. But that's perhaps a larger subject for discussion, but yeah, I think it's good that we have a voice in the technical uses of these materials, and that voice is heard by these decision makers.
Yeah, to me, I mean, this links back to one of the IGS's key kind of missions, which is the appropriate use of products, and using the right product in the right place usually means it's going to work right. Whereas if you use the wrong product in the wrong place, it's not. But that then gives the whole industry kind of a bad name. And a lot of that's just linked back to design. These are decisions you need to take up front, and know that if it's in an exposed environmental environment, you might have to make a different choice. You got to put something in there that's got UV resistance in it. If it's there for a very short time, you can use a recycled product because it's only going to work for a very short time, and then you're going to take that out again. So it's all about thinking about what needs to get installed and how long it's going to need to be there for, and doing that thinking up front, and making sure when you go to market, you've got that thinking clear, so that when suppliers see what you want, they give you the right kind of products.
And
Sorry, Sue. While we have the microplastics thing up there, I have to get this off my chest because it's a hot button for me. Geosynthetics are a trivial contributor to microplastics. The root cause of microplastics is obviously improper disposal of materials. And there's a short story I used. If you build a bridge and reinforce it with geogrid or high strength geotextile, and people ask, well, what's going to happen to that textile over the course of its life? Well, that bridge is going to be there for 100 years, and that textile is going to be buried underground, sitting there quietly doing its job. Meanwhile, the first day the bridge opens, some guy is going to walk over it, throw a plastic water bottle into the river because he's an ass, he or she. And that's going to contribute more to microplastics than that bridge is going to do from a geosynthetic perspective, probably in the first century of its use. We're wasting time talking about microplastics.
I think there are definitely bigger contributions on that sort of waste compared to how geosynthetics would be beneficial, I think, to the whole environment. I would also think that IGS, it's really a good bridge in between, the industries, the engineers, authorities, and decision makers. We provide a lot of information, giving I think webinars as well to actually educate the listeners how geosynthetics would be able to be helpful in whatever issues that they're actually tackling. Yeah. So if we are carrying on into the benefits of geosynthetics, differentiated into different categories, I think there are a few points that we can make to the audience in terms of agriculture, in terms of natural disasters, how geosynthetics would be able to be helpful in a sustainable way in terms of designs, in terms of preventions. The first topic is more on agriculture. I think it's probably one of the most important industries in the world that really contributes to the sustainability of human, I think. Yeah. So, Jonathan, would you be able to provide some insight to it in terms of how beneficial geosynthetics would be able to help in agriculture?
Yeah, there's a few key ones there. So that reducing seepage is one of them, and one of the key uses of geosynthetic barriers is in water canals, when you have to move water from one place to the other to irrigate crops. You don't want to lose a whole bunch of that water to the ground. So there are really efficient ways to line these canals with geomembranes and then protect them as well, so that they last a long time. So you also, once you get the water to a place, you might want to store it and use it over time, and therefore a dam or a pond could again be lined with a geomembrane, even with a composite barrier if you're really worried about losing water to the environment. You could also put a floating cover over the top of that pond to prevent it evaporating. So there's a lot of different ways that geosynthetic barriers can help save clean water that you are using to want to irrigate crops or provide potable water for that matter. The bit about waste and methane we've spoken about. Geosynthetic barriers, geomembranes specifically, provide a really efficient way to separate those from the environment, both from seeping into the ground and from getting out to the air. And it allows you to tap those gases off and use those to generate power. So there's a lot of good ways that geosynthetic barriers can specifically work in this area.
Yeah, sorry, Preston. So there's a point I wanted to make from the Malaysia sort of about experience. It's tapping on Jonathan's explanations. For the palm oil industries, I think there is a requirement for the estate owner to actually capture methane, so that they are more environmental friendly in terms of the whole process of processing palm oil. So there is the usage of geomembrane as coating covers to actually capture methane in this sort of industry, and that actually demonstrates a way of sustainable sort of development. Yeah. Sorry for cutting you, Preston. Yeah.
No, that's pretty much hits on what I was going to say. Is, when it comes to agriculture, a lot of what we're doing is environmental protection. So we're preventing contaminated fluids from escaping into that area where crops need to be grown. So another example of that are brine water ponds. This water needs to be contained because it's not safe to just dispose of that into open land that could be used for agriculture. But when we talk about agriculture, another one, Jonathan, you mentioned floating covers, but biogas reactors are another nice implementation of geosynthetics, and often that's done with cattle waste and other waste byproducts from the agricultural industry that's manages to actually generate energy directly from those waste products, but you couldn't do it without these membranes that can capture that gas.
Correct. Yeah, and then the whole protection of the soil against erosion. There's a myriad of geosynthetic products, turf-free reinforcement mats, high performance turf-free reinforcement mats that are meant to be left there for a long time, silt fences. So there's a lot of products, and it's an ever evolving field. I think we'll get to it a bit later on, but there's work that has been done to erosion protect the back ends of levees or flood control bunds that you can't sustainably do any other way. To try and haul in riprap rock against the back of one of those is going to be enormously expensive and damaging to the environment in itself. Whereas this product comes off a roll, you pin it to the back of the bund, and it's basically prevents catastrophic failure. So there's a lot of powerful uses of these products.
That's correct. And I think we also can relate it to water security then, because a lot of time agriculture, it's relevant to water securities, and it also relevant to potable water. How are we able to maintain the qualities of the waters for bigger communities? So in terms of the benefits of geosynthetics, I think a few of you definitely have some opinions on how we are able to use it to actually to secure water to a country, to communities. Boyd, do you have any comments on this?
No, I mean, nothing different than what we've added before. On the line item there about geosynthetics using less water, I would just make the comment that, generally these materials are compared against quarried rock, stone, sand, etc. And if you learn about quarrying, it's an extremely terrible process, and it uses a hell of a lot of water in its operation. So, again, geosynthetics are made from oil and gas. They're polymers made from feedstock that's coming out of the ground. But when you look at companies' environmental product declarations and compare that with operation of an open quarry, it's a better choice. That's all there is to it.
The other key thing in terms of preserving water quality, it gets into kind of what I keep myself busy with, which is separating waste that is just a part of living in a modern civilization from getting into our drinking water and groundwater. And in places like South Africa, there's led a lot of the kind of barrier developments. They do that because it's a water scarce country. If we pollute any part of the water, there's not going to be enough for people to drink. So using geosynthetics to separate waste from the environment is a real key function.
Yeah, and I think in Australia as well, Preston probably will know that I think there have been quite a fair bits of rainwater harvesting sort of project that actually uses geosynthetics as a barrier to actually capture water for water security purposes.
Definitely. I mean, out in Western Australia, you have very sandy soils and infrequent rainfall. So one of the applications of a geomembrane is to basically function as a catchment and to capture that rainwater. And you can do that on quite a large scale. So not only does every rural property have, systems to collect rainwater off their roof, it can be done for municipalities as well.
That's true. Yeah. Right. If we are looking into natural disaster preventions, I think this is probably a hot topic now in Australia and New Zealand. We are having high levels of flooding happening. So probably Preston and Jonathan, both of you, some
Well,
comments.
the fires are gone. We moved on to floods now.
Yeah, we get fire now in the east.
Yeah, this is a. I mean, it's a very topical topic. Yeah, New Zealand's recovering from a recent cyclone that caused a lot of devastation on our east coast. A lot of what they call stop banks here, or levees were breached because there's so much flood water coming down, and I think there's a lot to be learned from the response in America after Hurricane Katrina about rebuilding those flood protection measures, but building them back better, putting engineered geosynthetics in them so that that catastrophic failure mechanism doesn't happen. You keep the majority of the water inside the river where it's supposed to be, and even if you do get some overtopping, it doesn't take out the whole measure. So I think there's a lot of opportunity to build back or reinforce existing flood protection measures, and the coastal erosion is very much a hot topic here as well. With
and the Gabion guys deserve a big nod here, because there's thousands of kilometers of road that's protected from rockfall and landslide. The road couldn't be there otherwise if it weren't for the geosynthetic protecting the roadway and keeping it safe and secure.
Yeah, and it's down to something as what we would think simple as putting a geotextile in before you put that gabion in, creating that filter so you keep the soil behind and don't let it wash out. There's trying to do that with a natural material, and you've got to build up a natural filter would take a lot more material to get exactly the same outcome as something that comes off a roll off a back of a truck.
And I think similarly for coastal erosion as well, we see tubes and backs being used as a substitutions to natural resources, what do you call it? Natural sort of ways of building and breakwaters, building groins. I think that is another part of preventions that we can actually use by constructing it using geosynthetics.
And I think the time, to put one of those things up, you can do it fairly quickly. A big geobab filled with sand pumped from the beach, you can do that rapidly. And often you need to respond to these things rapidly because something would be changing. Whereas to try and build that thing in a with natural materials would take a lot more time.
Yeah.
And I would add that, much of the coast essentially has engineering involved with it because humans live near the coast. And so there's a lot of engineering that happens there. And that's when you have these structures like, you might see gabions or geosynthetic sand containers. But there's also examples where geosynthetic sand containers work in conjunction with the natural environment, where you can restore mangrove areas and work with the natural environment to provide flood protection in a more holistic way where you might never even see the geosynthetics.
Surf and wave protection.
Exactly, yeah, and artificial reefs, which are entirely buried, these sorts of things. So there's some really interesting use cases there as well.
I think how do we use geosynthetics? It's really, I think there are a lot of creative ways that we can actually utilize the materials. It's really limited by our imagination, I would say. So yeah, so probably more engineers would be more interested into how geosynthetics will be able to be utilized in the future. I think there will be more application that uses the materials in the future. So I think environmental protection is definitely one topic that all four of us are involved in probably daily. We have been talking about what they call the lining systems. We have been talking about water security. I think all of these points towards environmental protection towards the end of the day. So there are a few points that are listed here, and I think any of you, if you have any comments to chip in on how do we actually use the materials to protect the environment. Preston, for example.
I think we've hit most of these with the exception of mining. We haven't talked about mining, which is a big deal. You know, the human race continues to need special materials coming out of the earth. We as a species have unfortunately left hundreds, if not thousands, of levees that were built without geosynthetics around the world. And some of these are starting to fail, which is killing people, which is a problem. I had a discussion the other day, and the answer to the levee problem was first build a time machine and go back and put any sort of geosynthetic layer in these levees. And it sounds like a joke, but it's literally that simple. You know, even a drainage layer, a minor barrier, a barrier that functions poorly would probably keep most of these disasters from happening. So there's a strong geosynthetic contribution to be made to the mining industry and making it cleaner, because it's necessary to keep all of the 8 billion of us alive.
I guess my only point on this, and it's kind of triggered by the mining one, and a bit of a plug for the TC barriers, is there are new materials being made all the time. There's a lot of R&D going on in the industry, a lot of testing, a lot of academic institutions getting involved in testing performance, and the kind of landfill environment is almost mild compared to some of the environments in mining, with high and low pHs, really high loads, and there are materials being made and developed that are more attuned to dealing in those kinds of environments. So again, it's about picking the right product and putting it in the right place, and not just going with any kind of standard spec. It's so we run a lot of webinars as well, where we get guys in to talk about research or product development, so that you stay abreast of this honestly fairly rapidly changing field.
I guess final point I would add on the mining is there's two phrases you hear a lot about here in the mining community, and that's mine closure and social license to operate. So these are two things that are more prevalent today that and historically weren't there. But mine closure meaning there needs to be consideration made for what happens when this mine is finished operating, and it needs to the standard that's evolving is that the topography looks more or less unchanged, and so you have to make these fairly dramatic impacts that a mining operation can have on the landscape. You have to rehabilitate that in a way that's going to last for a long time. And so geosynthetics are a tool to do that. And then the social license to operate is something that's more serious. I mean, the tolerance that people have for long-term impacts of mining operations is an important consideration, and it has to be factored into what the mine intends to do long term with that site. So it's just a couple of interesting points where geosynthetics can play a huge role.
Yeah, and what that mine, what impact that's going to have on the environment, and a lot of that we can manage by using the geosynthetics correctly.
Yeah.
Amen.
And if we are talking about connecting peoples, I think that the population is growing, cities are growing as well. So I think the connections in between the cities, in between suburban areas, it's very important to be able to have a more sustainable sort of economic growth in the country. So I think all four of us here probably have experience in terms of geosynthetics and
Let Preston go. He's the UN Sustainability Goals guy.
Yeah, well, I think these, sustainability is, it has a lot to do with the environment, but it has a lot to do with other features as well. And, connecting people, development of critical infrastructure, there's 17 different goals. And I think this slide hits on many different ones that perhaps isn't on the front of everyone's mind. Roads, railway, airport, these are important pieces of infrastructure, where they're not going away anytime soon. So they need to be planned, considered, and then built efficiently with minimal use of resources. And that's where geosynthetics can really help.
And I think that the skills of using gravels without the geosynthetics, it could be pretty unimaginable if we are only using natural materials to build infrastructures. So that's where actually geosynthetics would be able to help a lot. Yeah, that's my take on it.
Yeah, and I mean, even if you're building a road over soft ground, I mean, a historical approach that made me to dig everything out and bring hard fill in. So you got to build this far above ground, you got to dig a whole bunch out. Whereas now, you can use really clever systems of geotextile wrapped stone columns and reinforced platforms, where you can put with a lot less fill, you can get a road that's going to work as well over an area, and you don't have to dig out half the earth to get it done.
Yeah, that's true. Right, and I think we are at our last topic of discussion for today, which is really the economic growth, economic development globally, and geosynthetics I think have a lot of benefits in terms of these topics. We've talked about cost saving, we have talked about the accelerations of constructions and the reductions in materials. This is probably relevant to a lot of applications. And any panels, any comments on that, if you want to add, and how it would be able to help them?
Well, we've got a winning cause. Throughout my entire career, I've been happy because this stuff really works. It does what it's supposed to do. It does it in a less invasive manner. It's generally economically viable. The IGS started the Educate the Educators program because one of the important parts is we need to have engineers know about this when they come out of school. But our industry continues to grow, and it's because we do what we say we can do.
I would add, just highlighting your bullet point here, reduce usage of materials. I think one thing we perhaps haven't touched on yet was, quarrying can have environmental impacts, but actually also can have real physical visual impact to the landscape. So this extraction of materials, there's various costs involved with that, environmentally, visually, and financially. And reducing usage of materials, geosynthetics often are extremely high strength materials, which gives you this huge range of opportunities to use a lot less material in situations where the natural stone aggregate alternatives would be much more significant.
Yeah, the big challenge in this area is engineers are trained to be risk adverse. They'll rather do something the way it was done before because they saw it work before, so they'll do it again. So it's about learning and being open to the fact that there are different ways of doing things. And through my involvement with the IGS over the years, the best way to do that is to attend webinars, to attend the conferences that the IGS puts on, because at a lot of those you'll see case studies, and you'll see a case study very similar to the problem that's in your head at that time. and you'll see how someone else has solved it. And I think that gives engineers more of a or satisfies their risk worries a little bit more. And when they can see the products being used, they can see that they work. And you can see that there's a way to do it with geosynthetics that would use less of the materials. Like I'm thinking building a retaining wall using geogrids and using the material from site as fill rather than importing fill. Little things like that. If you see it work, and you can save money, you can save time, and you can end up with a better product.
I think similarly to what Jonathan has mentioned, the durabilities of the materials, I think it's pretty incomparable. There are a lot of benefits that we can actually pull from the durability of geosynthetic materials in terms of saving money, increasing the construction, and also to reduce the usage of materials. And all of these links to how geosynthetics would be able to function, would be able to help in the projects, in the development. So that's our very last topics here, and maybe we wanted to have some closing remarks from the panels to some takeaway for the audience. Trigger some creativities.
Go to the website, look at the sustainability information. We covered most of it, but there's still things that aren't there. The Natalie Tuz's lecture on geosynthetics and the ebooks on the geosynthetic sustainable development are there. Again, copies of all this information. Go to the website. That's my message.
Yeah, mine's be brave and try something new.
And I'll just have a little unusual closing remark just to share is, one of the very first use cases of plastics in general when it was first discovered was actually to replace the mass harvesting of horned animals and ivory and whale bones. So there's, that last slide, mitigation of natural disasters. I mean, you can almost imagine, sometimes you don't get credit for saving the disaster, preventing disaster that never happened, but you can only imagine the dystopian nightmare of had we continued industrializing the ivory industry way back when. So I think it's kind of a interesting historical points on it, just stepping away from geosynthetics slightly, but that's my final closing remark, and I totally support Boyd's message, and go visit the sustainability page of the IGS website as well.
Yeah.
Thank you, audience.
Yep, thank you.
Yeah, thanks, Boyd, Preston, Jonathan, for joining us in this webinar. I hope that the audience have some takeaway and some creativity in their mind, future on how geosynthetics will be able to work for your projects. If you have any questions, please feel free to use our Q&A functions or email us at info@acigs.com. So that's the end of the recording. And if you have any questions, please feel free to use the Q&A function. We can address them, we can compile them, and send it over to our panels so that they can actually answer your questions personally. Or you can send an email through info@acigs.com. I will leave the room open for a few more minutes so that you can have time to write down any questions. Thank you for the time for attending our webinar. So hopefully I'll see you guys soon in the near future. So we'll probably have a few more webinars coming up. And for some of you that are following ACIGS on LinkedIn, you might realize that we are doing a roadshow in Auckland, in Melbourne, and Brisbane in June. So stay tuned for more information. It will be on pavements and railways. Thank you for your time.
Thanks, Sue.
Thanks, Jonathan.